What would you do if your entire cluster died right now? I mean, completely gone. Nodes wiped, etcd empty, nothing left. Could you get everything back exactly the way it was? Every app, every config, every secret? Well, I can, and it takes me about as long as making a cup of coffee. Let's talk about it. Hello friends, Mircea here. A while back, I showed you how I set up Kubernetes in my home lab using Talos Linux. To this day, that's still my preferred way of running Kubernetes, and it is what powers my home production environment as we speak. That video, however, ended a bit abruptly. We had a cluster, but nothing running on it. I mean, sure, you could kubectl apply everything manually, but in this video, I want to make the case as to why that's probably not the best way to go about it. Today, I'll show you how I declaratively manage my entire cluster using Flux, a GitOps controller for Kubernetes. We'll cover what GitOps actually means, how Flux works internally, how my GitOps repository is structured, and what happens when everything explodes. Let's start with GitOps. GitOps is essentially what the name implies. It's ops or operations handled through Git. In a nutshell, it means that instead of SSHing into machines and running kubectl apply manually or executing ad hoc scripts, you just declare the desired state as code and then push it to Git. Then an agent, and believe it or not in this day and age not an AI agent, that is running on the system will pull down those changes and reconcile the actual state with the desired state. And this is an important distinction to understand. GitOps tools are generally speaking pull-based, so they're not waiting for some CI to push the changes to the cluster. The cluster itself pulls the changes from Git and then reconciles the actual state with the desired state. Fundamentally speaking, we are simply automating the steps that we would manually have to do otherwise. Steps like pulling the manifests from Git and then applying them to the cluster. And this is actually one of the reasons why I really like Flux as a tool for this instead of, say, Argo. And I don't mean that Argo is not pull-based or anything like that. What I mean is that I simply prefer Flux because its architecture maps cleanly to how Kubernetes works internally. We have small controllers, each responsible for a very specific task, each with its own set of CRDs. And those CRDs map out really nicely to the commands that I'd have to run manually in the terminal. Once you understand that mental model, Flux becomes really intuitive. Let me show you. You can see here that I already have Flux installed and running in my cluster. What I want to focus on today is what Flux actually does once it's running in the cluster. All you need to know right now is that there are three-ish main methods to get Flux installed. First, there's the official Flux bootstrap CLI command, which I can't honestly say I'm a huge fan of. Then, there's the official release manifests. On every new release, the Flux team, if you scroll all the way down here, publishes this install.yaml file, which is a single YAML manifest with all of the required objects to get Flux installed. And then you can just right-click this and copy the URL and reference that in a customization. That's what I used to do when I started out with my GitOps repository. Then, there's the new kid on the block, which is the Flux operator. And I think you can guess which one I went with. You can see here the Flux operator is installed and running in my cluster, and I recommend you use that approach too because of a few reasons. First of all, it's a first-party Helm chart, or well, actually it's two of them. It's one chart for the Flux operator itself, and then another chart for the Flux instance. And this is important because of a nifty little feature of Flux, which allows it to take over and manage Helm releases that it didn't create itself. This matters, at least in my case, because you can see here in my bootstrap directory in the homeops repository, I have this Helm file in which I'm bootstrapping all of the core services that are needed before any application can run. You can see here I'm installing Cilium, my CNI, then I'm installing the Flux operator, and finally I'm installing the Flux instance, and this chart installs Flux using the operator CRDs and then links it to my repository. From that point on, Flux can take over all of these manifests right here and everything else in my repository and then manage itself. What that means functionally speaking is that if I push a version bump, for example, or more realistically speaking, if a renovate pushes a version bump right here, well, Flux will actually upgrade itself. There's nothing that I need to do manually, and that's not so easily achieved with the other installation methods. And on top of that, The Flux operator gives you a couple extras that the other methods don't give you, such as an MCP server or this web UI right here, which gives you some nice observability into what's going on inside your cluster. Anyway, back on topic. The first thing you may notice when you install Flux in your cluster is that it's not actually a single application. It's a set of controllers that are all working together to automate everything. If you look here, besides the Flux operator pod, we have the source controller, which handles all sorts of source-related operations, mostly fetching artifacts of all kinds, like Git repositories, Helm repositories, or OCI repositories. Then we have the customized controller, which handles all of the kubectl or rather customized related operations. The Helm controller, which as you can guess handles all of the Helm related operations. And finally we have a cool one, which is the notification controller. This controller can receive incoming events from the other controllers running in your cluster, and then it can emit them as notifications to external systems such as Slack, email, Discord, whatever. This essentially allows your cluster to ping you if or when something goes wrong. Each of these controllers comes with its own set of CRDs. So if I open up a new tab right here and I go into K9S and look at all of the CRDs in my cluster and filter out all of the Flux CD ones, we can see right here, for example, we have the Git repositories, the Helm repositories right here, and the OCI repositories, which are all in the source.toolkit.fluxcd.io API group. What this essentially tells us is that these resources are handled by the source controller right here. So if something's wrong with them, for example, this is where you need to look for logs. The Git repository, for example, is more or less the equivalent of a Git pull or a Git clone command, whereas the Helm repository is a Helm repo add. The pattern here, I guess, is that all of these resources map to some sort of go fetch this artifact command. Then we have the customization resource right here, which is actually the only resource in the customized.toolkit.fluxcd.io API group. So the customized controller right here is only handling one type of resource, this customization. And this essentially is more or less the equivalent of a kubectl apply-k command. You can think of it like this. The source controller will pull down the Git repository, and then the customized controller right here will use a customization to run a kubectl apply-k to a certain path within that Git repository. So the source controller fetched the artifact, and then the customized controller applied the contents. Similarly, we have the Helm release object right here, which is the only resource in the helm.toolkit.fluxcd.io API group. So this means that similarly to the customized controller, the Helm controller right here is only handling the Helm release object. This is more or less the equivalent of a Helm upgrade -- install command. Again, the source controller may pull down a Helm repository or an OCI repository, and then the Helm controller using the Helm release object will do a Helm install of the chart that the source controller pulled down. I won't go into much detail about the notification controller in this video. It's a nice quality of life addition, sure, but it doesn't directly relate to the core GitOps workflow. The same actually goes for the other two controllers, which I actually have disabled in my installation right here, the image reflector and the image automation controller. If you're curious about any of these, let me know in the comments. I don't think they warrant a dedicated video, but maybe a blog post, who knows. Alright, now that we understand what each of those Flux controllers actually does in theory, let me show you how I use it in practice. This is my home operations or home ops repository. Every single thing that's running in my cluster is defined somewhere in here. There are two main directories that we're going to talk about today: apps and Bootstrap. Bootstrap we already covered, that's how Flux gets installed and connected to this repo. Let's talk about what happens after that. Let's say I just push the commit to this repository. What's the actual chain of events that gets that change from Git to running into my cluster? First of all, the source controller is sitting there watching every 5 minutes or immediately if I manually trigger a reconciliation, and it does the equivalent of a Git pull on my repository. And this is handled by the source controller via a Git repository object. So if I open up K9S here and I go into my Flux system namespace, and I do a search for a Git repo object, you can see I have this Flux system Git repository. If I describe it, you can see here in the spec section that the URL is my actual Git repository, and then we have a reference for the branch, for the main branch here. So this is essentially a git clone on this URL with the -- branch flag set to this value. And since this is a controller that reconciles the state continuously, we also have an interval right here. What this means, and what you can think of when you see this, is that it's essentially a while true loop that runs a git pull on this URL with this branch and then does a sleep for this interval. This is an oversimplification, but as a mental model, it gets the job done. So, the source controller pulled down the changes, and now the next operation would be to apply the manifests, and that is handled via the customization. And I want to take a short pause here, because the naming convention right here is genuinely unfortunate. There are two completely different things, and they're both named customization. We have the customized native one with the customized config.ktest.io API group, and the Flux one with the customized.toolkit.fluxcd.io API group. Same name, different API group. From this point on, I will call the Flux customization a Fluxtomization so we can actually tell them apart. So, the Flux system Fluxtomization right here does the following. It references the Git repository that the source controller just pulled earlier, and then it does the equivalent of a kubectl apply-k in the apps directory, as we see here in the path section. And again, since this is a controller, it does that every 10 minutes or so. What this essentially means is that the source controller initially will pull down the changes using the Git repository that is created, in my case, by the Flux instance Helm chart, and then the Flux system Fluxtomization, also created by the Flux instance Helm chart, will apply my apps directory right here. And that single apply is the entry point for literally everything running into my cluster. So, let's take a look in my apps folder right here. If I open up my namespaces here in K9s, you can see that they're actually matching up. We have database system, we have default, development, finances, Flux system. Basically, the structure here is that within apps, I'm doing one folder per namespace. There's also some structure within the namespaces. You can see I have a namespace.yaml which creates the actual Kubernetes namespace object, and the customization applies the namespace, and then it also applies a subdirectory per app. Within each app directory, the structure is also consistent. You can see I have another customization right here, which applies the app Fluxtomization. I'm giving it the name of the actual app it's deploying, so in this case it's the Cloud Native PG operator. I'm again referencing the Git repository that was created by the Flux instance. So this Flux system repository is actually my homeops repository. I'm applying this path within that Git repo, so essentially this directory right here. I'm applying everything to the database system namespace, so this is the equivalent of a -n flag or -- namespace. And then I'm doing that every 10 or so minutes. I'm telling Flux to prune everything, so that essentially means that if I'm removing some manifest from that folder, so from app here, if I'm removing all of the manifests, I want Flux to uninstall everything. And then wait actually tells customize to wait for the resources created by this Fluxtomization to be reported in a healthy state before reporting the Fluxtomization itself to be in a healthy state. So, again, this app Fluxtomization applies this directory right here. And within this directory, we have a customized customization, which applies the OCI repository and the Helm release. The OCI repository is a resource managed by the source controller, and it references the OCI path for the CNPG Helm chart. So this will pull down this Helm chart at this tag and refresh it every 1 hour. Then I have a Helm release object handled by the Helm controller. I'm calling it Cloud Native PG. I'm referencing the OCI repository the source controller pulled earlier, so this one right here. And then I'm applying the Helm release with these values. So essentially, this is a Helm upgrade -- install on this OCI repository with these values. So the full chain of operations from a pushed commit all the way to a running workload looks something like this. The Flux system Git repository created by the Flux instance Helm chart fetches the new commit or the repository. The Flux system Fluxtomization applies the apps directory in this repo. The namespace level customize file creates the namespace and references each app directory. And in each app directory, I have a new app fluxtomization that applies the actual app manifests within that directory. It's just customized all the way down. This also scales pretty cleanly too. I can add a new application to database system, I don't know, maybe a new operator or something. Well, I can just drop a new folder here, reference it in this customization file, and then within that folder, I need to create a new fluxtomization to reference the app subdirectory within that operator, and then just do the regular Helm installation or whatever installation method for that operator. One fluxtomization per app is usually all you need, but there are patterns that come up fairly often. Let's take Cert Manager for example. That one is running in my network system right here. You see, the thing with Cert Manager is that it's an operator. When you install it, it deploys the controller and, importantly, it also installs several CRDs into your cluster. Certificate request, cluster issuer, you know the drill. The thing is, I don't want to only run Cert Manager, I want to use it. I want to create a cluster issuer and tell it to talk to Let's Encrypt to create TLS certificates for my services. And the problem is that if I were to put the Helm release and the cluster issuer manifest in the same fluxtomization, there would be a race condition. The customized controller will try to apply everything at once. And if the CRDs are not yet registered, when it tries to create the cluster issuer, the Kubernetes API server will, rightfully so, just deny the request because it has no idea what a cluster issuer is. The operation would be rejected. So the solution is to split it. And you can see right here I have an app directory which sets up the OCI repository for the Cert Manager Helm chart, and the Helm release which just installs that OCI repository with these values. Then this is applied with the app fluxtomization right here. Another fluxtomization I have is for my issuers. So you can see this Cert Manager issuers fluxtomization, also targeting the network system namespace, applies the issuers subdirectory. The key part here is this depends on section. You can see that this fluxtomization depends on Cert Manager, which is running in the same namespace, and also on my 1Password Connect running in my security system namespace. What this essentially means is that the customized controller won't even attempt to do a kubectl apply-k on this path unless this particular fluxtomization and this particular fluxtomization are already reported as being healthy and ready. So the Cert Manager fluxtomization will apply the controller and install the CRDs, and once the actual deployment reaches a healthy state, the fluxtomization that installs Cert Manager will also reach a healthy state, and only then, when also 1Password is healthy, but only then will the customized controller apply this issuer's fluxtomization, which will create my cluster issuer right here. You will see this operator plus config pattern in a few other places. For example, in my metlb deployment as well. I have this app fluxtomization, which installs the actual operator. And then I have this config fluxtomization, which depends on the metlb operator and the CRDs being installed. And this config fluxtomization creates my L2 advertisement and my IP address pools. Sometimes the split isn't necessarily operator and instance. It could just be two independent deployments of the same tool. The external DNS deployment right here is a prime example of that. You can see that I run two independent external DNS deployments. One that's managing my Cloudflare DNS records, and one that is managing my internal MikroTik DNS. But the thing is that they don't necessarily depend on each other. So the Cloudflare fluxtomization right here, you can see applies the Cloudflare subdirectory in the external DNS folder from my Flux system repository, but it doesn't depend on the MikroTik one, and neither does the MikroTik one depend on the Cloudflare one. The mental model right here is fairly simple. I give one fluxtomization per logical unit of deployment. One thing that deploys independently gets its own fluxtomization. One operator that installs the CRDs gets split from its instances via a depends on, and also multiple instances of the same controller or the same app with different configurations get their own fluxtomizations as well. And the thing is, because every single one of those fluxtomizations traces back to a file in this repository, and also because of the folder and naming convention I have right here closely matching my namespaces and workloads running in Kubernetes, everything in the cluster has a clear paper trail. You can look at any resource right here running in my K9s, And then you can easily trace it back to a file in Git. And at that point, you can see exactly who pushed it, who modified it, who committed everything, and when. That is GitOps. Alright, I've been talking long enough. Let me actually show you. What I'm going to do is that I'm going to delete my media namespace right here. Image, Jellyfin, Navidrome, all of it gone. Then I'm going to let Flux bring it all back. So you can see here the namespace is terminating and all of the applications are slowly being torn apart. All of the pods, services, persistent volume claims, all of it. Now, what I will do once the namespace is gone is that I will manually trigger a Flux reconciliation. Normally, Flux would also pick that up on its own because I have that interval set in just a few minutes, but I don't want to just sit around and wait. And what's happening right now, you can see that the Git repository is being reconciled by the source controller, and then the Flux system Fluxtomization created the new media namespace, and within it, we have the new Fluxtomizations for each of the app. Then, the app's Fluxtomization will create the OCI repositories right here, and then the source controller will pull down all of the Helm charts for those repositories. Then, the Helm releases get created, and this is handled by the Helm controller. So now it's doing a Helm install on all of the applications and you can see them all slowly coming back. And just like that, everything is now reinstalling every app, every config, every secret, exactly as it was, right? Well, almost. You see, there's one thing I glossed over in all of this. GitOps gives you your infrastructure back. Your deployments, your configs, your network policies, your TLS certificates, all of that lives in Git, and Flux will faithfully reconstruct it. But there's one thing that Git doesn't store. Your data. My photos in Image, my watch history in Jellyfin, the playlists in Navidrome, that all lives in persistent volumes, on disk, on my NAS, completely outside of Git's awareness. Flux only recreated the PVCs, but the data that was in the PVs is gone. So, when I said at the beginning of this video that I could get everything back up and running after a full cluster wipe, was I lying? Well, no, but I only showed you half of the truth, because GitOps is only half of the equation for me. The other half is Volsync, a Kubernetes operator that handles the backup and restore of PVC data. Crucially, it is configured the same way as everything else in this repository, declaratively in Git reconciled by Flux. So when you can see here the Volsync pods, what's actually happening is that Flux created the PVCs and then Volsync kicks in and pulls the latest snapshots from the garage instance running on my NAS and restores the data automatically, no manual intervention required. And this is the part that makes everything take as much as making a cup of coffee, because Flux creating the manifests is actually pretty quick. What takes a while is Volsync pulling the data from the S3 endpoint running on my NAS. If that's something you'd want to see more of, Volsync, PVC backups, and the full stateful cluster disaster recovery scenario, well, let me know in the comments section down below. If there's enough interest in it, I'll put something together. Alright, that's a wrap on this one. To summarize what we covered today, GitOps is pool-based declarative operations handled through Git. Flux implements that with a clean set of single-purpose controllers, each with their own CRDs that map directly to the CLI commands you'd have to run manually. The repository structure is just folders, all the way down. One folder per namespace and then one subfolder per app in every namespace. Each logical unit of deployment gets its own Fluxtomization, and the using depends on to enforce ordering where it matters. If you want to go deeper, my repository is linked in the description. Feel free to poke around and steal whatever's useful. At the end of the day, open source is open source. And absolutely, let me know if something doesn't make sense or if you do it differently. I am always curious to learn how other people are structuring their GitOps repositories. If you found this video helpful, well, the subscribe button is right there and it's waiting for you to click it. That's all I have for this one. Thank you so much for watching and I'll see you in the next one. Cheers everyone.